Good morning, everyone. Let's start the last day. Thanks for being here. Today, I will talk about how to accelerate your application development with the power of templates. Reusable templates serve as a great foundation to your LabVIEW projects, bringing structure and consistency to your projects. But building a template isn't that easy and takes careful planning and decision-making. I will walk over the key areas to consider when building a template and share our own experience when we developed our template. My name is Stefan Glauer, and I have worked as 9 years as a development engineer at the LabVIEW MBH in CLA. And to know why templates are so important to us, I need to give you some context what we do at the LabVIEW. The LabVIEW is located in Ottobrunn near Munich. We run 1,200 employees with different business fields like automotive, aeronautics, geodata, defense, and space. And in our division, we develop highly customized test systems. So we're around 40 to 50 people in our division, combining everything, electrics, mechanics, and software development, and deliver turnkey solutions for test systems. They're all highly customized. On the bottom, you see 3 examples of our test systems. On the left, there's a spring and damper test system with 2 electrohydraulic actuators. In the middle, you see a brushless DC motor tester, which is using Varistand as a climate chamber. It has a power analyzer. On the right, you see the heavy multi-axis shaker. This is a 6 degrees of freedom earthquake simulation test bench. And what all these test benches share in common, they have a real-time system, they have a PLC, they have different actors and sensors, and they always have moving components like electric motors and hydraulic cylinders. And all of them are controlled via a custom-built LabVIEW user interface controlling the system. So now a new project starts. How to start a new project? Create a blank project again, rebuild the basic user interface again, rebuild the basic VIs again, and start thinking, actually my older projects had good VIs, had a good user interface. Maybe somehow, how can you reuse it? Hands up, who's familiar with this? So let's start thinking of an easy way to start a project. But the problems with this setup, with this approach, it's time-consuming. You have to build everything from scratch. You re-implement everything you had before, and it's untested. You have to write new unit tests for it. The UI will be a bit different, inconsistent. The style will not be the same. If the project structure is different now, there's a lack of knowledge how the project is structured. So if another team member joins the project, maybe it's a bit different than before. And there's no streamlined process to get up the first prototype of the project and have everything set up for you. So our solution is, we started building templates for us. And if you think about it, LabVIEW has many templates already built in. I consider the UI elements you can use as a template. You have the VI templates. You have the VI backgrounds you can use as a template. You have the project templates, like the active framework template or QMH template. They are very helpful to getting started, but they're not fitting your needs exactly. So let's start customizing these templates for you. The first thing we wanted to solve in our team, when we develop user interfaces, they're often inconsistent. You see a mix of different UI styles, like classic, silver, or fused design. You see different element positions, like the buttons on the top of a string, on the left of a string, on the right of a string. There are different text sizes and fonts used, and especially often, we often did see different layouts, like the curator elements which are used, and the white font panel. So the first question we asked ourselves in our team, how can I create a consistent font panel design? Let's start with a blank user interface. How do I start? Should I put in clusters, decorators, graphs, or control indicators? And where should I position them? It's a great blank area, and you don't know where to start. What we did, it's a different approach. We set a custom background for all our VIs. Why? Because it creates a color scheme for us, and for us also it creates a ribbon bar on the top, the gray area where we later build out ribbon elements. If you don't know it, you can put custom backgrounds in LabVIEW resources backgrounds folder, and then can use them if you right-click on a scroll bar, and then they pop up like the other custom backgrounds. Next thing we added, we created a strict number of front panel layouts we want to use. So we decided to have here 12, here a bit more of them. They divide the front panel in different sections, and you have a bigger area on the top where you can put a graph, and have smaller areas on the bottom where you can put your controls and indicators. Or a 2x2 design, so you have two graphs on the right, and for the other two boxes you can use the controls indicators on the left. Why we did this? It helps to create consistency for us. If you divide the front panel in different boxes, there are only a limited amount of number of boxes. It's easier to know where to position your user elements. And it enforces layout rules. And actually, we have to now think less about where to position elements in the user interface. One thing you see here on the top left of it, this blue box, this is a dropping helper for us. So if you put that on the front panel, it matches the size of the ribbon on the top, and it's positioned at zero position, and they can delete them. And now the position of the front panel elements of the layouts is always the same on the same position. That was the idea how we solve it, to drop it on the front panel. And last, the next thing we added, we built custom ribbon user elements. Why we did this? Because they're a mix of icons and text, so it's much easier to understand what happens. It creates a consistent place where you put user elements on the front panel. It's space efficient, and one good thing is many people know it from Word, from Excel, and now if they look at the top, they see all the available functions. If some functions are grayed out, you can not use them. If they're not grayed out, you can use them. And now you have an easy overview what functions are available in your user interface. So that was these elements together. And the last element is now what we also built is a specific custom controls indicators for our company, because they create a specific look and feel for the application. And now you don't have to consider which front panel element should I use. Should I use the silver design? Should I use the fuse define? And if we need new elements in the team, then they're added to this controls, then you know I can only use them. And combining all these elements together creates our custom user interface we use all the time. So the VI backgrounds, the front panel layouts, the ribbon elements, and the controls and indicators. And now we have no mix of the UI styles. We have a consistent look of our user interface. And it's much easier and more clear how to build a user interface in our team. This helped us a lot. And one thing we always sometimes do is if we have created a design we liked, we put it to the VI templates. So click File Save As, and save as a VI template in LabVIEW, and now we can easily create a new VI out of it. One thing you have to consider if you're doing that, it will also copy the block diagram. That can be a good thing, it can be a bad thing. And maybe if you're using a framework like DKMH, it's better to build a DKMH module template for it than using this approach, if you want to have a usable front module with DKMH. So this all together we put in a UI palette, and this is called now a UI design toolbox, and it helps us to create our user interface. So, but often our applications are more complex than just one front panel. We have a mix of different pages for different system functions, like a test process window, a system overview window, a manual control mode window, or configuration windows of different actuators or of our system. So it should be possible to combine several of these front panels into a bigger picture. And so actually what we did, we had our standard user interface you see on the right. We did use all the time, but it was not that reusable before. So the second question we asked ourselves, how to build a reusable standard user interface? And if you abstract the front panel you see, actually there are several buttons on the top representing tab pages. We have several buttons on the left representing a second hierarchy of navigation. And we have two subpanels. The main window subpanel where you inside the VS you sit before, like with the ribbon elements. So if you press a button, it will also change the ribbon elements because they're in the sub-VI you insert there. We have a cockpit area for every test bench, which shows the system state, like emergency stop, if the doors are locked. We put that one time for every test bench. It can be exchangeable, we had no need to it, but that is a cockpit area which always stays the same. And we have a status bar on the bottom where you can show strings, and also have a progress bar. And now if you press a button on the top, it will change the second layer, like the buttons on the side. And if you press the button on the side, you change the main window area. One thing is, this is a fixed user interface. It's on 1080p, that we have no scaling options for it. But it works for us because all test benches are always delivered with a 1080p monitor. And to get that now reusable, actually what we do on application start, we inject an array of VI references and tags, which VIs are available for it. We'll see later. Also, we have a model manager. Actually, now we inserting the classes, which can be shown. And then you have a configuration file for the front panel that defines what happens on which button press, how the button names are, and how the subpanel mappings are. And that creates our standard user interface, and it starts when the application starts and sets up itself. And now that's a reusable approach for us. What we did then, we had this front panel, created a new project, added it to the project, set up everything we want in a project for us. It's like the basic folder structure, the configuration files, example configuration files for the user interface. Also sample modules we added, and a launcher VI, and a build specification. And that's our starting point now for our project template. And what we did then, we added this to the LabVIEW project templates so that we can start it with one click. To do this, you need to copy the source code and create a metadata file and put it in the LabVIEW project templates directory. And there's a great NI knowledge article about how to do this. And now we can create a new project and have everything set up for us just with one click. What happened then? We used the template, new features did emerge. So like a user right management, email notification, and other features like event log windows, sensor calibration windows, test bench diary, unlockable sub-tabs, etc., etc. Then the next question we asked ourselves is, do I know which features I want to include in the templates? Should I add all these features to the templates? We say it depends what fits your needs. We have application-specific functions, like test sequences only for this project, or a custom user interface window for like a hydraulic cylinder you want to control. I wouldn't add them to the template. Also, you have reusable components, like if you have a control, like an API to a power supply or a climate chamber. I also would not put them in the project template because use them across projects, but not all projects. What we put in our template are more the infrastructure functions who fits everything together to create a consistent user interface and a project. So like the standard UI, also we added the user management because it works in tandem and together with the standard user interface. We added the event logger, and that is growing. And what you also see here are the black arrows. They show the dependencies. And that's important to keep in mind. So the common library functions should not depend on the project template functions, but the other way around. It is okay for us that the project template functions depend on the common library functions. And the application-specific functions for us can depend on both, on the project template components and the common library components. One thing to keep in mind here, if you have an application-specific component, like we are using DKMH, the business logic of the module, for example, the classes which do the work, they should be independent from the project template components, but the wrapper around it, like the messaging, should and can depend on the project template components. Also, one thing you see here, I said it's called components. That stands for, it can be a DKMH module, it can be an actor or a library. It's a more abstract word for different parts of the application. And now, what happened? Our project is larger now. You see, you have a standard user interface, we have an expert user interface, we have two test sequences, like a sweep test sequence, a sign test sequence, and we have two hydraulic cylinders. And then we have data logger and the post-processing, and also the project template components. So the next question we asked ourselves is, how can I manage other application parts and components? And for that, also it should be easy to add and remove components to the project. It should be possible to flexibly combine these components. And each component should support different configurations, like the hydraulic cylinder has a different PID setting, or the email module has a different settings, or the sign sequence has a different frequency. So to solve this problem, we added a component manager to our template. What does the component manager does? Actually, is just two classes. The component manager itself has an array of all available functions of the project, components of the project which should be managed. So every component we want to manage needs to implement an application component class and inherit from it, and implement required abstract methods. They generate a contract, so the the component manager can control the application components. And here you see the very simple form of contract that was okay for us. It's launch the component, configure the component, stop the component, and get the UVI reference to get the front panel of the component and add it to our standard user interface. When the application starts, now all components are injected to the component manager, and now the component manager can manage all of them. One thing you can do here is add a plugin structure, but we don't have a need for this. I had no need for it now, maybe in the future. So what's possible with the setup? Now the component manager gets a configuration file with a list of components which should be started on application start, or you can switch it in runtime actually. And this determines the boot order of the components which are managed. And also it has a path to a configuration file and a tag what configuration the individual component should use. And the individual components can share a configuration file with different tags or have a unique one, and then they can set up themselves. To do this, one thing what we did is for all configurations, we have just one folder. So the component manager configuration file is on the same level as the individual component configuration files, and so the paths are all relative. And what we did, what's possible with this, now you have can support different system variants. And for each system variant, we made a custom folder with all configurations. And we have one level higher configuration file which points to the system variant we want to launch. And then the system variant launches. For example, we have the variant A with the standard user interface, the sign test sequence, only hydraulic cylinder 1 is used. And we have a variant B with the expert user interface, a sweep test sequence, and both hydraulic cylinders are used. The data logger and the post-processing is used by both variants. That's the way we create our applications. So just with some configuration files and folders, we can create different variants of a project. It's in the same executable, but it's easy to switch between the variants of the test bench we develop. And the system is configured at the runtime. So now we have both the UI design toolbox we use and the project template we use. And the last question we asked ourselves was, how do I want to handle installation and versioning? And for us, what we did, we built two IVPM packages, one for the UI design toolbox and one for the project template. The first one just puts the toolbox on the UI palette, but also copies the backgrounds and via the template VIs to the right directories. And the project template VIPM copies everything to the project template folder, so the metadata file and the source files. To do the copying, we used the source file settings in the VIPM. It's a bit tricky to set up the first time, but then it just works. And now, what's the good thing about it? If you install this package in VIPM, our team is set up to create new projects. It enforces versioning, so everyone knows which version of the project template we are using. It's easy to update if you have a new version. We just shared in the team, install everything, and we have the new template then. So, but one thing is, actually, if we want to update old projects, we have to replace it manually. We wanted this because we want to support different versions of the project template. And for us, it's just exchanging one folder and maybe changing some small things if we want to update an old project to a new version. But maybe in future, we will put things in the VI-lib, but we're still considering what we want to do there. So when we summarize this, when we combine everything of this, the front panel toolbox, the standard UI, the common functions, the component management, and the installation and versioning, this creates a great foundation to our projects. If you compare it with our initial challenge, now for us it's easy to set up a project with just one click. Around 40 to 50% of the project is set up. The functions are battle-proofed because they're used all the time. The user interface is much more consistent, and it's easy to create new user interfaces. One important thing is the team knows the structure of the projects because it's all the time the same, so it's now easy to switch persons between projects. And we have, especially one thing, we have a tool that supports us to get our initial prototype up and running very fast. And if the project is set up, we can easily make a mock-up of how the user interface and everything should look as next step. So, in conclusion, for us, we're using our templates now 3 years and it's still growing. So maybe in the future we will add continuous integration to it and other functions. So it's a growing process. For us, we reached much higher code quality, faster project setup and development times, and a strong team understanding of how this all works because it's documented in Confluence and everyone knows how it works. And what we started now is adapting this approach to a PLC development and also started building a project template there so that if you combine this both templates, it's easy for us to have initial test bench set up and running in no time. and for you. One thing, I think it's a general concept. So the first bullet of my presentation actually was choose a framework it depends on. It's an important choice, but I think it can be done with any framework. Build and add what fits your needs. That means that worked for us. Your use case can be different, and it's important to start building what's important for you. So maybe you have completely different requirements, like a scalable user interface. And start small and watch the template grows. We see it now, it's 3 years in use, and it's still growing and evolving now. I hope this inspires you to start building your own template. Thank you. And any questions?
Hello. I'm wondering if you have one person on your team that's dedicated to updating or making changes or adding new features, or is it something that multiple people in the team take part in?
When we started, just I developed the template, but now we have more people in it because if I'm not there, it's important that you have several people who can build and create up this template, involve this template. So not just one. So we're around 5 to 7 developers changing, and at least 2 knows how the whole framework and template works. Yes.
Thanks so much for the presentation. I really liked your ribbon bar with all of the icons on, and I've tried doing things like that myself before, and I was just wondering, like, did you buy an icon set? Are they vector? Did you draw them? How did you do it?
We have a very sophisticated team member who did draw them by himself.
Oh, nice. Within LabVIEW or outside?
No, I think he used Inkscape. I can ask him what he used and can say to you.
Oh, cool. Thank you
So
so
they are
much.
really custom created. They're not created in LabVIEW, and they're put in LabVIEW with everything with the hovering and so. It was much work. I know he had spent much time doing it, but now we have it. Yeah.
Great, thanks.
Hi, thanks for your presentation. Do you put the custom UI elements on all the sub-VIs that are layers down, or are they mostly on the upper visible?
They are only
UIs?
on the visible elements. So APIs, we don't use just the classic ones because they don't have dependencies and they shouldn't. So.
Hello. Oh, sorry. Hi. No, okay, it's working. The question is, it sounds that you have many people in your company. When you're releasing the new template, how you are sure that everyone has the newest version?
It's a bit difficult. So we do it by sending an email and hope that everyone installs the new version. So.
Is there no issue when they have older version or something?
Actually not, because if you have older projects, they have their own version of the template because you have to exchange the folder. So now the old projects are still working, just don't have the new features. But then in the team round, we have to say, did every user an update? So we have a team round every Monday, and then we can send a reminder, did you update the template?
Okay, thank you.
Hi, Stefan. I have a question here. In the middle. I have a question regarding your shaker, your big shaker, which you showed on the first slides. I know that these kind of machines are used for standardized type tests, for example. Did you had to recognize any kind of standard or requirements regarding your software development, and or did you integrate this by yourself completely? Or
actually, this test bench is in our company, and we do the tests. It's a different team of our company, and yes, we do all the standard tests. We can talk about it. they use this test bench since over 20 years. Is in use. It's in our company to do some health tests on something like this. So, yes.
But did you develop it completely within your company?
The control system, yes. It's a MATLAB model running and doing the transformation matrix. So there's 7 hydraulic cylinders in use, and it was developed by us internally. I wasn't there when it was developed, but we updated it with a new user interface. So we had the old user interface only with MATLAB, and then updated to LabVIEW in a very thin system now.
Okay, thank you very much.
Great stuff. Thanks, Stefan.